Okay, hello everyone. Today our topic is about pressure. We will discuss about pressure in the solid, liquid, and in the gases. Okay, so let's move on to the first part, the pressure in the solid. Okay, so just imagine you're going to a gym and maybe you want to exercise and want to make your have more muscles. Okay, and if you're taking a bottle of water with you, we can find that if you're maybe exercise for a long time, you need many of water, right? So for the supplement, maybe you'll take 1 liter or 2 liters of bottles, right? So just put a little water on your hand. Maybe you will find that, oh, the water is very heavy and it makes your hand very uncomfortable, right? So the first statement is that forces increases that will make your hand feeling uncomfortable. Okay. And like in the second example, if you want to decorate your room, maybe you are using the pin, right? Use a pin to make some decorates just fixed on your room, right? So maybe the pin has two parts. The first part is the needle part, and the second part is the head part, right? Maybe the needle part is very sharp, and if you just make it to stick maybe into some people or some objects very sharp. So if you unfortunately make it on your finger, it's just very hurt and also very uncomfortable feeling, right? And if your finger is touching the head part, we can say that the head part is very comfortable than the sharp part of the needle, right? So we can find that if it is very sharp or the area of the section is very small, that will make the uncomfortable feeling increases, right? So here we can find here forces increases and area decreases will make the uncomfortable feeling increases, okay? So here we can use a formula that uncomfortable feeling equals to the force over area, right? Because at here, forces increases, the total value of the fraction number increases. And once the area decreases, total value of the value will increases, okay? So here we can use it to represent for the pressure, okay? So we just described the uncomfortable feeling as meaning of pressure like this one. Okay, so pressure equals to force over area. Okay, so here is how to calculate the pressure. And remember that pressure's unit is Pascal because it is defined by the famous scientist Pascal. Okay, so we use PA to refer for the unit. Okay, so just have an example like here, you can find a wind is blown onto wall, right? So maybe you ask that, oh, teacher Mai Lin, so I'm wondering if it is a solid pressure or a gas pressure. But remember that how the force applied on object. And here you can find the contacting surface is a solid, right? It's a wall. So we can say it is a solid pressure, okay? So here you can find the area 6 meters square and the pressure is 100 Pascal and you find the force of it, okay? So now you can use in the formula that pressure equals to force over area, right? And here you can use in force equals to Pascal or pressure times area. And pressure here is 100 Pascal. And area here is 6 meters square. And once we times together, the value is 600 Newton. Okay. So here is the pressure in the solid. Okay. And then let's move into the pressure in the liquid. Okay. So here you can find there's a cubic here and maybe a cube of liquid right here. And how to calculate the pressure in the liquid? You can try to use in the formula we have talked about that pressure equals to force over area, okay? So for this liquid, if you're using the force over area, that the total weight of the liquid just have on the very base area, right? Like this way. So then you can use in the formula that force means the weight, right? The weight of the liquid and over the area of the liquid. Okay, and the weight we can use in the formula we have talked before that weight equals to mass times gravity over the area, right? And for the mass of the liquid, we can use in the formula that mass equals to the density times the volume, right? So here we are using mass times density, mass equals to density times volume. Okay, maybe you are maybe not familiar with the formula, but you can try to imagine that density means the number of matters in a per unit mass, per unit volume, okay, like this way. So you are like the stone has a very big density and the maybe you can find the cotton has a very less density, it's like this way, okay? So this is how we using the density to calculate, okay? So now you have learned about how to using the pressure and using the density. You can put the density's formula into this, and here you can write down the pressure equals to mass times gravity times over the area, and it also equals to the density times volume times gravity over the area. Okay. So here you can find the volume just equals to the base area times the height, right? Because this is a formula in the mathematics. Okay, so here is the density times the volume. Here is area times maybe the height and times the g over the area, right? So you can make this into the density times gravity times height, right? So this is the formula of the liquid density, okay? So you can try to imagine, remember that the density times gravity times the height, okay? So this is represented for the pressure in the liquid. And remember that the height here means that the distance from the top of the liquid to the places you want to measure. Like here means this is the edge, okay? It doesn't mean the real height for the liquid. It just means like the distance from the bottom to, sorry, from the top to the measuring places, okay? So here is the distance, okay? So to remember that pressure in the liquid. And also the unit here is Pascal, okay? Okay, so let's move into the next part, that pressure in the gases, okay? So pressure in the gas is a formula we don't need to remember right now, but we can just see in this figure. And here you can find the table represented for the fixed temperature, the pressure, and volume changes. Like here, when the pressure equals to 200 kilopascal, and the volume of the gases here is 50 centimeter square. Like when the pressure is 250 kilopascal and the volume is 40 centimeters square. Okay, so meter cube, sorry. And here we can find measuring all the number of the pressure and volume and then make it as this figure right here. Okay, so you can find here is just like a function of y equals to 1 over x, right? It's like a reverse function, the y equals to x. So when you're very careful, you can find here is a relationship between the pressure and volume, right? Because here, when you using the pressure times the volume, you'll find that is a fixed value. It equals to 10,000, right? So this is how we can use this to calculate the pressure times the volume, okay? So here is how we can calculate this kilopascal times centimeter cube, okay? Like this one. So you can use this formula to calculate the pressure in the gases, okay? Okay, so you just need to understand that pressure times volume is a constant. That is all right, okay? So let's quickly move to the next part, that pressure from the air, okay? So the pressure in the air is very classical problems. Like imagine you're on the plane, maybe when you first time take up airplane, maybe your ears are very uncomfortable, right? And that is why, because we can say that is because here is air pressure in the air, so maybe your ear very comfortable. Okay, so let's make a specific reason for why your ear is very uncomfortable when you're taking an airplane. Okay, so like here is if you are on the ground like this way, maybe here the air is much more than on the plane. So here you can find many air particles and molecules here, and you are surrounded by them, okay? And here the pressure of the air may be equals to the outer side, and also in your body there's full of the oxygen, okay? So here it becomes a pressure equilibrium. And after that, when you goes to the plane, maybe here is a plane, maybe I'm not good at drawing, okay? Okay, here's a plane, and you're inside of this. But you find that in the plane, although there is an air conditioner system, but there's still less air in the crew. Okay, so you can find here. Okay, so in your body there's full of the air, but outside there's lots of the oxygen. Okay, so maybe for this, your ear has a very strong pressure in your head, but there's less pressure in the outer side. Okay, so maybe here is a pressure difference, and which makes your ear very uncomfortable. Okay, it's uh, like this way. Okay, there's a lot of pressure in your body. Okay, so how to solve this problem? Okay, so we can just use a chewing gum, or we can just take our breakfast or dinner, right? That is because when your mouth starts to chewing, you take in a lot of breeze and take in a lot of air in the total cabin, right? And then your pressure in the body equals to the pressure in the other side, and then our new equilibrium, okay? That is how we can use this way to solve this problem, okay? So here is the evidence of the pressure from the air, okay? And you will also find why there's always a like a air oxygen mask in the plane, right? That is because once there are some problems with the airplane, maybe it is broken and maybe there's a crack, make some outer air just fluid into the cabin. Maybe here the pressure of the airplane will just decline very quickly, okay? This is why we have an oxygen mask, okay? So here we can find that pressure equals to a very constant number that is defined by a scientist called Torricelli. Okay, and Torricelli has determined many like experiments for the pressure from the air, and you can using this equipment to find the pressure from the air. Like here, the Torricelli just finds that once he puts the liquid inside the apparatus, and he finds that the top of the liquid just increases. And if you just still to use a vacuum pump to remove the left air, you'll find that the level of the liquid also increases like this way. Okay, so and finally, it will just reaches a very constant value or a constant height like this way. So he has a calculation and he finds that there is a constant number or like a maximum number for the air pressure. So after calculating it, this is 1.0110 Newton per meter square, or you can also set 1.101 times 10 fifths Pascal. Okay, so here is the difference in the pressure. Okay, just remember this pressure from the air. Here's the difference. Okay, so we have learned about different pressures in the daily life, like the pressure in the solid, pressure in the gases, pressure in the liquid, right? So let's have some exercise, okay? Please just try to solve this problem, okay? Explain why this way of moving across the ice is safer than the walking and using your understanding of pressure in the answer, okay? Okay, so let's back to our question. Like here, you can find a person just like he's like sleeping on the ice, right? And he said that using this way, he can become more safer than walking, right? So how this way can be safer? We can find that he's on the ice. So maybe here he's on the solid, right? So we can using the formula that pressure equals to force over area to calculate the pressure, right? So here, using the formula pressure equals to force over area, that the person's weight doesn't change, whether he chooses to lie down or like he chooses to stand up, right? So force is a constant number. But the area right here, area just increases after he lies down, right? Because he has more contacting space with the ice when he lies down, right? So once area increases, the total value of the pressure just decreases, right? So here we can say that the pressure equals to the force over area, like this way. And once he lies down, the area increases, and which makes the pressure on the ice just decreases, right? So which makes him become more safer, right? Which makes person safer on the ice. Okay. So I think it's very easy for you to understand for this problem, but remember how to write down such answer, okay? So first you have to determine what is the formula here. You are using the pressure on the solid. Okay, this is the first thing you have to remember that. Okay, and then to describe how it is changing like area and the pressure in such formula, okay? If possible, you can also determine that the weight doesn't change because the person weight is a constant number, okay? So here just to determine how it will make an influence on the pressure, okay? Okay, so let's move into the second question and just to try to figure out this problem. And this problem is to find the total pressure at the point X, okay? Okay, so let's moving back to our question. If you didn't finish your question, you can just pause the video and try to calculate and rethinking more. Okay. So first of all, I have a question. So have you ever played the Minecraft or like the Lego? Okay, like these games. Okay. So if you're playing you have played the Minecraft before, maybe I think this problem is very easy for you to understand. Like here, you can find there are three blocks right here. You're just thinking as in the Minecraft, there is a water blocks as a very below. And after that, we have a ice block in the middle, right? Because in the Minecraft, just water and ice are both block, right? And maybe at the top of the two blocks, we have the airspace like this way, right? So here, airspace can take a place just at the top place, right? So here is the air, okay? Because once you play the Minecraft, you will find that maybe air is also a block, right? Because like when you're placing the sand or like placing the other very like not very heavy blocks, right? It's very easy to just fall down, right? That is because there is the air blocks density in the coding of Minecraft, okay? Because the air is very heavy, and maybe for the sand and for the other very like very less density object, it can just fall down very easy because they have a more like density rather than the air. And air also has some higher density rather than the ice and water. So you can just placing ice, placing a water, like no need other things to not, oh, no need another like to making a force on it, right? This way, okay. There's a water block on the sky, or just a dirt block on the sky, right? So there is a very interesting characteristic of the game, okay? Here you'll find how to call the act, and we can find here three blocks on the act, right? So you can just put them together, and the pressure, the all acting on the act, okay? So you can find, if you want to call it the pressure act, it equals to the pressure of the air plus pressure of the ice, added with pressure of the water, right? Like this way. So the pressure of the air is a constant number we have called it before, that is 1.01 times 10 fifths Pascal, right? This is for pressure on the in the air, right? And for the pressure on the ice, like I said, using the formula that is force over area, right? So the force here means the ice weight, right? So here you can find we have the ice mass of 690, and if you're choosing the G equals to 10, we can using the mass times G means the weight, right? And the area here you can find the total area of the pound is 5 meters squared. So you can over the 5 meters squared like this one. And for the pressure in the liquid, in the water, we can use the formula that equals to the density times gravity times height, right? And density here is 1,000, and the gravity is maybe 10, and the height of here is maybe 0.45. Okay, so here we can calculate it is 1.01 times 10 fifths, and here is like 6,900 over 5. Maybe we have to add it with 1,000 and maybe 380, okay, Pascal, and also added with like 4,500 Pascal. And then once you add it together, that means the total pressure at the bottom of the atom. Okay, so here is how to calculate the problem. Just to remind that we have three pressure, we have to add them together, and this means the total pressure. And pressure can have a superposition just like the example we have given in the Minecraft. Okay. So this is our today's lesson. Hope you can really understanding about the pressure and to distinguish the difference between the pressure in the solid, liquid, and the gases. Okay, so see you next time. Bye.